wait a few minutes for the other members to join. Okay, so it's time. We are going to play the team's promotional video first, and then we're going to go to questions.
A significant public health problem worldwide are burns. According to statistics, in Mexico, at least 200,000 people suffer from burn injuries annually, and almost 2,000 die from it. Although most of these injuries could be avoided with an education on fire management or with good job security, the reality is that the healing process is expensive, painful, and above all, not accessible to most people. The final cost of the treatment for these injuries is approximately $5,000, which is equivalent to almost 20,000 minimum wages in Mexico. Burns can be caused by radiation or mechanical, chemical, thermal, or electrical energy. From all the cases mentioned before, the ones caused by electricity are the most dangerous and represent 20 to 25% of burn injuries. And even though electricity isn't the main cause of burns, Mexico and a lot of third world countries are extremely exposed to this source, literally. The electrical system in these nations tends to be disorganized and tremendously near to people's houses. So the question here is, how can we create a cheaper and more effective treatment? Well, the answer is in silkworms, or at least in their cocoons. These silky cases contain a protein named fibrin, which is a promising molecule in burn injury treatments since it has excellent biocompatibility. In addition to this, growth factors play a major role in the wound healing processes, so combining these substances can become a potential therapy. But this sounds very expensive, and it is indeed. However, there's a solution. If we place the coding genes for fibrin and growth factors in a bacteria and a yeast and let them express, these molecules can be produced massively in a cheaper way. After that, the final product can be treated to create films that can be easily applied to patients. This way, we, the Biomed CCM team, can create a more sustainable and cheaper treatment for burn injuries. If you liked our video, feel free to contact us and check our Instagram. Thanks for watching.
All right, thank you, Ale. Judges, if you have questions, please raise your hand using the tool. Yes, Mauricio.
Sorry, my entire team can access the Zoom. I don't know if there is a problem. I think like 4 or 5 people can enter the Zoom.
We don't have anyone on the waiting room. Can you please check if they're using the right link? I'm going to send it to you again.
Okay, thanks. Sorry.
That's okay. So we'll wait just a couple of minutes until the rest of the team joins.
Thanks.
Okay, so 2 other people joined. Can we begin?
Sorry, could you repeat? I didn't hear.
Yes. 2 other people came in, or 3, I'm not sure. Can we begin?
Yes, please. Sorry. It's okay now.
Okay. All right. So Yadira, please.
Okay, thank you, Christian. So, hello, team. I have been enjoying your video and also your project, and I have a quick question about your proposal. You said that you developed a model for the displacement of the molecules of collagen and the fibrin that you are going to produce as your biofilm. So, but I couldn't find the computational simulations for that model. So, do you know if your circuit is likely to work, or do you know what other kind of considerations should we take into account to produce the biofield that you are making of?
Yes, the computational problem was that we couldn't afford the competition problem. Is well, our comps well didn't handle that kind of work. But if we know that it's we're not gonna work, well, first of all, our computational problem was that we know that this type of film is gonna affect the growth of the. So we know that this film has to be in a very specific way so the tissue can regenerate in appropriate way. So the model is about that. We are going to. I'm sorry, I have another camera because my mic doesn't work on my comp, so I don't know if I'm.
Oh, that's okay. Go on.
Okay.
Yeah.
And well, and that's all. The competition problem is just about to fit that film in appropriate way for the tissue to grow in appropriate way, so it doesn't go backwards with like the film work. But if we just put it in an appropriate way, the tissue will grow in some bad issues, and it will make even worse to this injury. But the values of our models are in like a range to thesis and works that show us that it has like potential to work. We have almost like 2 parts that we can get because of time. But yes, in speaking of range of the values that we know that we're gonna need, like speed, like fluke, like biomechanical kinetics, we know that it's gonna work in that times of range. There are other values that we can afford of time, but that's what we're talking about in that model. I don't know if we answered the question.
Yeah, it makes sense. Thank you.
Thanks.
Thank you. Mario, please, your question.
Thank you, Christian. Well, guys, I'm very happy to meet you finally. I have only one question regarding your integrated human practices. I would like to know if you have previously considered all the local and national regulations you need to apply to your product before taking it to the market, because I think it's a very great approach for a very big problem, but I don't know if you have this in mind.
Yeah, so for the integrated human practices, we also consulted different specialists, such like Dr. Roberto Sanchez Sanchez, who is a known investigator and also a collaborator in INR, which is the Institute of Rehabilitation here in Mexico, and he is really common with these kinds of, procedures. And also he gave us some options to how we could regulate our film. For example, he linked us with a specialist in COFEPRIS, which is the engineer Delia Sanchez, who is now the doctor who created the pharmacopoeia for the new edition for the pharmacopoeia, and she gave us, for example, advice on what kind of medical device this film will be. For example, she listened to our proposal and she told us that, okay, this is a medical device in type number 2, and also the different classifications that are in order for them, in order to make it viable in also the market. We already know that there are films in other centers of, well, burn centers that are already approved by COFEPRIS and also FDA. So we didn't include it yet in our proposal because we are still checking all the regulations, at least here in Mexico, with all the NOM and all the issues properly. So we like in the future to also include it when we have all the information and all the regulations we, well, at least we need for this kind of medical devices.
Perfect. Thank you.
Thank you. Emmanuel, your question.
Thank you, Christine. Hi, team. Nice to meet you. It's a good work. And I've only 2 questions. The first is, why you decide use the UTR5 from the insane gene? Are you sure that it will work in the bacteria, and why not you use an UTRT in the construction of the plasmid? This is the first question. And the second question, sorry, is, did you know that the fibrillin have a post-traductional modification? Because it could be a challenge. How you will solve this problem in your platform of expression? Thank you.
Of course, thank you. Of course, we knew we would have this kind of problem, and that's why we only use the E. coli. That's just a cloning vector, and we decided to use the yeast, that it's a eukaryote, to create the correct modifications. And we decided to use the UTR regions because we have 10 minutes left. It's kind of better, and it shows that it stabilizes in time and space the expressions of genes. And so that then we decided to use that instead. We thought that it was the best option.
Thank you.
Okay, thank
you. Did they answer both our questions? Sorry. Yeah, okay, good. Sriram, please.
Yeah. Hi team. So I would first like to congratulate for choosing this problem statement and for also proposing a very attractive solution or proposal. I think I already had a question which was asked by one of the previous judges on the modifications, which was also satisfactory from the answer that you gave. And the only other question that I had was something that's more on the downstream side of the project. Like, so once you have your, let's say, biofilm of the product, how do you hope to validate it? Like, is it already known from literature what sort of, let's say, small animal experiments you would have to conduct? Or so what exactly is your plan to establish the proof of concept with this product?
For example, well, in order to find the fibrin, we also had to check all the literature, what was being done in terms of injuries and also for the skin regeneration process. So in those articles, they tend to use little or at least small rats, where they use to remove a small part of their skin and have a rat for control, another rat for fibroin and maybe other growth factors, and also another rat that use common or at least treatment that it is already used now in the market. So they tend to show the improvement of the film in a range of 30 days, if I'm not wrong. So that could be a way in order to test, or at least the proof concept. Or we also check in another, in part of the literature, they created a skin graft. They simulated the skin on the lab, and they use different films or at least different growth factors in order to check how this could evolve in the skin, if it was regenerated or if the process was underdeveloped. So we have these two options. So we decided to take maybe a more non-invasive, because we are not to use animals yet, because that will be animal cruelty. So yeah. I think that a more suited way will be creating a skin graft in order to prevent.
Good. I think that's exactly what I wanted to know. Yeah.
Thank you. Naya, please. Oh, okay. So Manuel.
Hello, team. I have a curiosity. Is you never thinking about to put in your biofilm some antifungal, antibacterial compound that prevents some infections when you're planning to do some regeneration experiments, for example?
Well, for example, that is also a question that we recently prepared, or at least presented our project in our community, and they asked us the same question: why we didn't think about common infections that are really common with burn injuries? That is also a major problem when it comes to burn injuries, and we are taking little steps. First, we are focusing on the regenerative process and also what we can achieve with that, and then we will tend to focus on the part for the infections, because at the end of the day, the film is like a physical barrier between the environment and also between other infections. So it is important also for burns, or at least any kind of injury that passes through the dermis, to protect it or at least cover it. So for this stage, we prepare it only for the regenerative phase, but maybe in the future, we will aim for also to take into account also another infections. And yeah, I guess that's the answer.
Okay, thank you.
Thank you. Andrea, do you have a question?
Yeah, thank you. Hello, everyone. Thank you for being here for your project. I find it very interesting. And I wanted to ask a question as a follow-up to what Emmanuel asked. I was just curious about the strain that you're using, the Saccharomyces cerevisiae strain, so the LAS02. You explained that it has excellent transformation rates, but what else can you tell us about this strain? Why did you decide on choosing it, and how this presents advantages to your project, specifically in regards to the post-translational modifications, which is crucial to a project like this?
We did not really choose that strain because of its, well, yes, because of its great transformation rate, but also because it's completely safe to use. And the main reason why we chose that is because in case of it getting out or something being leaked from the laboratory, it's going to be completely safe. That was the main reason we chose that. But yeah.
Okay, could I make a follow-up question?
Yes, you have time.
Okay, thank you. What do you mean by safe? Sorry.
Like, for example, if someone gets to ingest it, it's not gonna be very unsafe for the person. It's not gonna get sick. Apparently, the FDA have some research about it, and they say that it's a completely safe strain because it may only cause minor diarrhea.
Thank you.
Thank you. Noé, please.
Thank you. Well, people, congratulations for your work. It's very interesting. My question is directed into what would you have in plan relating to letting a GMO microorganism into the nature? If you decide to apply the biofilm directly into the wounds of the microorganism, it will be alive. You have planned on how to prevent the GMO from escaping to nature, maybe an intraventricular switch or something that you can use to prevent it from set it free into the environment.
Of course, it is really important to think of that, but now at this stage of our project, we didn't really implement this because we wanted to have a solid base of our main project, and then we had to apply those modifications to avoid what you're saying. But it's something that we have to do in the next phase of our project. Like, for example, but however, we do have some. We would apply from some oxotrophy genes to make it more safe in case it got out, for example.
Okay, thank you very much.
Thank you. Andrea, do you have another question?
Oh, no, sorry. I just left my hand raised. I'm sorry.
That's okay. Do we have other questions for other judges? Yes, Mario.
Thank you. Guys, could you please clarify how are you addressing your inclusivity requirement for the gold medal, please?
As far as I can remember, we didn't feel that part, but for example, inclusivity in our team, well, this is a multidisciplinary team. We have members of different careers, such as like biomedical engineers, biotechnological engineers, also industrial, and also from different ranges of ages and also different semesters. We really like a multidisciplinary team, and also we tend to consider it for at least in our project, the different people who we can reach. For example, this proposal is made for Mexicans, but it can be also applied for all the world. At least it also has different modifications because everything in medicine related to comorbidities. I'm so sorry. It's such like diabetes, and also if people smoke or not. It also makes more complicated the things about our biofilm. But we tend to use a model that it applies for everyone, or at least in healthy, aspects or different environments. And I don't know if I answered your question.
Yes, thank you.
I just wanted to compliment the comment of my team leader with the fact that by making this our project recombinant, we try to reduce cost to the minimum, and that's like one of the main objectives of our project, to make this available for everyone, especially in third world countries, which Mexico is a part of. So we want to make this treatment available to everyone.
Very well, thank you. Matthias, if your question is quick, then we have time. I'll ask you to be brief, please.
Yeah, I just have a question concerning the purification process. So how do you consider to purify your compounds for the product?
Right now, it's going to be extracellular, so maybe we have to check it to make it actually in the lab, so we can see what are the best options to purify our proteins. But maybe taking into consideration that we're gonna make it cheap, maybe with chromatographies or something like that, we didn't implement his tags or these little tags to the circuit because we wanted, again, to make this very cheap. So maybe with some physical separations.
Also,
Thank you.
I'm sorry. I don't know if I can complement the answer.
Yes, we have 1 minute.
Okay, I will be fast. I will be quick. For example, here in our college, we have a laboratory that has all the devices that will allow us for the purification part. Also, we have a great team behind us, our PI and also our main advisors. They have knowledge about this part of the purification process, and also we have the resources in our college in order to do that.
Thank you very much. Well, thank you, team. Thank you, judges. I will ask the team to please leave the room, and you can continue watching the session on YouTube.
Thank you so much.
Thank you.
Thank you.
Meanwhile, we're going to wait for the next team to arrive.
I think Mauricio is still in the room and he's a member of the team.
Oh, let me remove him. Thank you, Robin. While we wait for the other team, judges, if you want to grab a water and go to the restroom real quick, you can do. Hello, Tári. How are you guys?
Hello, everything fine?
Hi.
Nice to see you.
Hi. Nice to see you too. Okay, so we are going to begin by playing your promotional video, and then we're going to jump to questions from the judges.
You are not muted.
Please mute yourself, yes.
La exploración de microorganismos del suelo antártico ha maravillado a la comunidad científica en los últimos años. Sin embargo, se han detectado peligros para la salud que preocupan a las autoridades, como genes de resistencia a antibióticos que producen beta-lactamasas, las que podrían llegar a cepas bacterianas en el continente, agravando la crisis de bacterias resistentes que afectan a Chile y al mundo. Se estima que en 30 años, cerca de 10 millones de personas al año morirán producto de la falta de antibióticos para las infecciones por bacterias. Considerando que Chile se ha transformado en paso frecuente para los viajes entre Antártica y el continente, la amenaza de la llegada de estas beta-lactamasas se hace cada vez más probable, poniendo en peligro a nuestro país y sus vecinos. Según cifras de la Organización Mundial de la Salud, más del 60% de los antibióticos utilizados corresponden a beta-lactámicos y gran parte de las bacterias patógenas se han vuelto resistentes a ellos gracias a las beta-lactamasas que los inactivan. Desde tiempos remotos, el pueblo yagán, habitantes de lo que hoy es el país más austral del mundo, salían en sus canoas a explorar el sur en medio del frío. Hoy, cientos de años después, quienes habitamos Chile continuamos explorando el sur. Hemos puesto las tecnologías de secuenciación masiva y metagenómica sobre las canoas que han recorrido el mar austral por siglos. Así, al igual que las comunidades indígenas de nuestro país, creemos que parte de las soluciones que nos permitirán sobrevivir se encuentran en la tierra más fría del planeta, la Antártica. Así nace Tári, o Tierra Fría en yagán. Para enfrentar este problema, proponemos una plataforma basada en biología sintética y computacional para evaluar el riesgo de beta-lactamasas antárticas y el desarrollo de proteínas inhibidoras de ellas, para luego producirlas en bioreactores. Tári también involucra acciones en educación, divulgación y gestión política. Este es nuestro aporte local para enfrentar de manera integrada la crisis global de resistencia a antibióticos desde el sur del mundo.
Thank you. Judges, if you have questions, please raise your hands. Yes, Noel.
Hello, Tári. Great group. Nice work. My question is directed from the modifications in the amino terminal and hydroxy terminal ends of your Trojan device. You are sure they are not modifying the 3D folding of the protein? They are not affecting their function and their functionality under further circumstances?
Please.
Hi, we wanted to know which protein you're talking about specifically.
You said in your work, you are modifying the amino terminal and the hydroxy terminal of one of the proteins in your Trojan horse device. Give a second.
Okay, thank you. Okay, so we are going to answer in Spanish and then we're going to translate in English, if that's possible. Okay.
That is possible if it's a student doing it, okay?
Sure.
Ok, en ese device, que es el Trojan,
In the Trojan device,
vamos a expresar la proteína BLIP,
we're going to express the BLIP protein,
que naturalmente posee secuencias de exportación periplasmática por un lado,
that it has natural periplasmic export peptide signals,
pero nosotros lo reemplazamos por una secuencia señal de exportación que ya está aprobada en los sistemas de IGEM.
but in this case, we replace the this part with an already tested part that is proof that it works in the IGEM repository.
En particular está aprobado en E. coli, que es justamente el hospedero que vamos a utilizar.
This has been proven in E. coli, that is our chassis for our proof of concept.
respecto al extremo C terminal, también es una parte que ya ha sido utilizado en sistemas de expresión de nuestro propio grupo de investigación.
And according to the C terminal, we have already used this modification, and it has been proven that it works without altering the rest of the protein.
Great. Thank you.
You're welcome.
Thank you. Yadvira.
Thank you. Hello, team. It's a really nice project, and I especially I really like your mascot, or I think it's a really cool block of ice, I think. My question is regarding to the integrated human practices, because I saw that you did a lot of work talking with the experts and stakeholders. So how did you integrate the feedback that you received into your project, and how did it help you to improve the project?
Hi. We met with various experts. Specifically, one of them was Carlos Lagos. He helped us see that it was needed for us a way so that our blip could enter the cell. That was one of the things that this type of interaction with expert helped us to shape our project. And also with the teacher Rosalba Lagos, she also helped us with preparing this with the microscene signal that has been studied in our university, and that's how we shape our project. And specifically, Carlos Lagos and his help was one of the most important things in this experience. As he helped us to model, to talk, and most of the things. He teach us a lot.
Sir, sorry, madam. I would like to add something. It's just that the integrated human practice not only involves like the scientific things, it also involves political things and the validation of the problematic. And in this case, something very important was the conversation that we have with the Undersecretary of the Ministry of Health, and also one of the headmasters of the Institute of Public Health, who validate our problematic and also told us that something that it's very necessary actually in our country is that there is no environmental surveillance. So that was one of the things that also we incorporated in our project.
Thank you.
Okay, thank you.
Mario, please, your question.
Thank you. Hey guys, happy to meet you. Congratulations for all your hard work. I have a question, an hypothetical question. Understanding that you are trying to find a solution for the antibiotic resistant development in bacteria, how will you use your project, use your knowledge, use your current expertise to replace the antibiotic resistance on all your plasmids? Because you are keeping using antibiotics on all your plasmids. So how can you change that?
Okay. Sir, are you? Do you listen? Do you listen to me? Can you hear me? Sorry.
Yes, we can hear you.
Yes.
Yeah, okay, thank you. We could change these markers, these selection markers, by axotrophic resistance markers. So axotrophic, yeah, markers.
Perfect. Can I make a follow-up question?
Yes, you may.
Thank you. So understanding that also this problem has a social and educational root, how would you address this in a big scale? I mean, maybe not only in your university, not only with a focus group. How could you re-educate or a big portion of the society on the use of antibiotics?
Okay, so we not only focus on one group here in our university, we did a lot of different classes, and we invited different kind of people, and our main goal here was to create this domino effect. So if we can just trespass or just give this knowledge to people, then these people can just give this knowledge to another people, and then we can just create this bigger effect. We also, with our stakeholders, such as the National Institute of Public Health, we addressed not only the scientific part of our problem, but we also addressed the educational part. So we were constantly working alongside with the scientific part and the educational part, making sure that we not only we were transmitting the scientific knowledge, but also we were de-escalating, we can say, the problem to normal words, so everyone here can understand the importance of the problem, and they can address and give this knowledge to people. It doesn't matter if they're kids or just older people. Go.
I wanted to add something. We only not did this like university focused stuff with the other two things that were addressing education. First, we had classes to high school students through our mentors. And the second thing, we developed an Instagram that reached many people outside of even Chile that helps spread this information to everyone outside of our community. And we hope this information can reach everyone. And we also are planning to do an ebook with every material that we did for this Instagram and share it internationally with whoever wants to learn about the anti-resistant microorganism, the resistant problem.
Thank you. Emmanuel, please.
Thank you, Christian. Hi, team. It's a big and nice work. Congratulations. And I love your model and simulation in AlphaFold. Congratulations. It's very good. It's very nice. And I a first question only. How you will try the activity of these molecules? Thank you.
Okay. We want to share a little diagram. Is that allowed? Okay.
Yes, that's allowed.
Thank you. So we wanted to make sure that if you're referring to the beta-lactamase or the bleep.
Beta-lactamase.
Okay, thank you.
We're seeing your juggle page. I'm not sure if that's what you want to show.
Oh,
okay. Now slowly, sorry.
Okay. Go ahead. Are you seeing our
yes
diagram?
Please go ahead.
Perfect. Okay. Yeah. Okay.
Entonces, utilizamos dos plataformas para evaluar la actividad de la beta-lactamasa. La primera es utilizando el plan medido Tári Glow.
So we had two different devices to assess this this activity. First, we have the Tári glow device that you can see here. This is in our E. coli chases.
Sí. Ya. Entonces, la idea de aquí es que la actividad de la beta-lactamasa va a estar asociada a una señal fluorescente roja.
So here, the beta-lactamase activity is going to be associated to the red fluorescence signal that is encoded in the mTOR system.
Y este ensayo es importante porque nos permite probar la prueba de conceptos para después evaluar los inhibidores de esta beta-lactamasa.
So this is important. This is a proof of concepts. This is going to allow us to then assess the activity of the beta-lactamase.
Entonces la idea es crecer estas bacterias en presencia de antibióticos carbapenémicos.
So we want to grow this bacteria in the presence of carbapenemic antibiotics.
Y en presencia de ello, nosotros esperaríamos que la beta-lactamasa reconozca estos carbapenémicos y se traduzca en la señal de fluorescencia roja.
So we're expecting that the beta-lactamase is going to address the presence of these antibiotics and is going to express this red fluorescent light emission, and we can then correlate the light, the emission light, the expression of the mTOR with the activity. This is going to be like a linear, we can say, correlation between the activity and the red fluorescent emission.
Entonces esto es importante porque en el ensayo que sigue, cuando expresemos nuestra proteína inhibidoras, nosotros esperaríamos que en presencia de ella inhiba la actividad beta-lactamasa e inhiba el nivel de fluorescencia roja como aparece en este clip.
So then in our second essay, we're expecting that this organism can inhibit the activity of the beta-lactamase with the expression of the blip, the BLIP.
Thank you.
Was that okay?
Thank you.
Okay, Sridham.
Yeah, congratulations, team. I think this is a very big and bold project that you have undertaken. So I just have one question, which also falls in line with what Mario already asked, which is with respect to the resistance that the bacteria can develop. So you're basically looking at giving a plasmid into the bacteria, which will code for a protein, which you call the blip, which will then inhibit the beta-lactamases, right? So one problem that we have with already the small molecule inhibitors is that so as Mario already asked, one way that the bacteria can overcome this is by expelling the plasmid, so your blip is not at all produced. But the other problem is that the bacteria can evolve with a mutated form of the beta-lactamase, which cannot be targeted by the protein that you code for. So have you brainstormed a little bit about this and figured out if there's a possibility to design blips in a way that even the mutated versions, if at all they evolve, can also be targeted by your blips?
I think you are muted.
Okay, so we're going to share another little diagram. So what we intend to do here is that the plasmid will be maintained because we use an antibiotic resistant marker that is different than the beta-lactam antibiotics. In this case, we use the DH5 alpha, that is REC A strain. So it has a lower frequency of mutation. So in that way, we are going like a step forward. We made sure that the marker that we used doesn't have a higher frequency of mutant. Yeah.
Was it clear?
Was it clear enough? I don't know if that answers the question.
Yeah.
All right. So Manuel, please.
Hello, thank you for your presentation. I think that your project is very nice project. I like. I have a question is, do you think that you can extrapolate your system to explore the resistance to looking for another, to extrapolate another antibiotic, or is just specific for this kind of an antibiotic?
Now, as we mentioned in our juggle, for example, in the discovery circuit, you can replace the CDS region with any class A or class D beta-lactamase. So our circuit, we designed and we thought from the beginning that just because we wanted to approach this problem and propose a surveillance approach to the project, we made sure that not only this worked with the BKC-like beta-lactamase and the OXA-like beta-lactamase, but it also works with another class or types of class A and class D beta-lactamases. So you can interchange the CDS part of the biobrick.
Well, can I add something? Yes. Also,
Yes.
Another thing is that you can use this device in another environments. So Antarctica is just a proof of concept, but you can apply it in another environments too.
Okay, thank you. Thank you for your answer.
Thank you. Do we have any other questions like the last one? Well, if not, oh, okay. Yes, Yadira.
Yeah, I just have a quick question, because I was wondering, why did you choose to measure fluorescence of a red fluorescent protein? Is there another way to measure the activity of your blip circuit, or no?
Okay, thank you for the question.
It's just that well, two things. We choose this because this was an optimized design that was previously by another item team, so it was like more easier to start with something that was previously made. Also, measuring fluorescence help us to have a more quantitative measure.
Yeah. And we're not only going to quantify with the red fluorescence, we also gonna do minimum inhibitory concentrations assays to then test the correlation between the red fluorescence emission and the activity of the bacteria. Yeah. Thank you.
Okay, thank you.
Thank you, team. Thank you, judges. That's it for you. So I'm going to ask you to please leave the room and continue watching us on YouTube.
Thank you very much.
Thank you.
Thank
Bye.
you.
Thank you for
Bye-bye.
Bye.
Thank you.
Thank you.
You already have the other team coming, but I'm going to wait a little bit for this team to leave. Hi, Juliano. While your team arrives, I'm going to ask you to please rename yourself with the name of your team, as well as your name, of course.
The Zoom just had a problem. Just a second.
That's okay.
Oh, just 1 second. One of our members is entering the room.
That's okay, we can wait a little bit.
Aí, quando ele... Liga a câmera. Senão vai aparecer a gente. Mas tem como colocar.
Someone has their mic on, so if you could please mute yourself while we wait for the others to join.
Thank you.
Você monta, Joyce, acho que eu assim, não?
Não, é.
Então, reduz o som. Ah, tá bem. Some of the team members are going to be here, so you can see everyone.
Yes, we can see everyone. That's fine.
Say hello.
Okay. Hi.
So let's start.
So we're going to play your promotional video, and then we're going to jump into questions. Okay?
Sure.
O envelhecimento é um processo comum a todos os seres vivos. No Brasil, a população idosa corresponde a 10% da população total, dos quais 81% possuem alguma doença crônica. Dona Maria é uma senhora com 72 anos e sofre com diabetes e problemas intestinais, doenças geradas por distúrbios metabólicos relacionados à idade. E como ocorrem esses distúrbios? Durante o processo de envelhecimento, há a diminuição da disponibilidade de moléculas importantes para a manutenção celular, como o NAD+, um cofator e substrato essencial para diversas vias metabólicas. A falta da disponibilidade dessa molécula desencadeia problemas no reparo do DNA durante a divisão celular, mas também na expressão gênica, na produção de ATP e o aumento dos níveis de radicais livres. Pensando nisso, desenvolvemos o Revita NAD+, um suplemento à base de leveduras probióticas que irão ajudar a suprir a demanda celular por NAD+, e retardar distúrbios metabólicos relacionados ao envelhecimento. As leveduras probióticas são organismos que, ao serem ingeridos, são capazes de colonizar o intestino e trazer diversos benefícios à saúde humana. Para o desenvolvimento do Revita NAD+, será realizado um estudo do metabolismo de NAD+, na levedura probiótica Saccharomyces boulardii, e com base na engenharia genética, selecionaremos genes específicos para superexpressar enzimas envolvidas na rota de síntese de nicotinamida ribosídeo, o NR, um precursor de NAD+. Será utilizado um promotor para induzir a transcrição de genes heterólogos em condições anaeróbicas e garantir a secreção do precursor, liberando-o no trato gastrointestinal humano. Com o Revita Nadimais, pessoas como Dona Maria terão acesso a um sistema simples e barato para o retardo de doenças que afetam a população idosa, e nós, como cientistas, tornaremos essa realidade possível.
Thank you, Ale, for playing the video. Now, judges, if you have questions, please raise your hand. Yes, Mario.
Thank you, Christian. Hello, guys. Nice to see you. I have a quick question. I would like to know what was your path on your ideas, construction, or conception, or the conception of your product, because I don't understand why you select an spray as your vehicle instead of maybe a topic cream or a gel or any other presentation for your product.
Sorry, would you mind question again, because your sound is like with a problem.
Okay, no worries. I would like to know the path for your idea or your product conception, because I don't understand why you choose to produce.
Can you hear me?
Yes.
Yes, we can hear you. Can you hear us? I think they cannot hear us. Can someone else from the team answer the question?
Okay, you can hear me now?
Yes.
Yes.
Oh, sorry, I had a problem with one of the computers, but could you mind asking again one more time? Because we really had an internet problem here. Sorry a lot.
Don't worry. I would like to know what was your path for your product conception, or the ideas that you take in order to take this product, because I don't understand why you selected, why you choose an spray as the vehicle for your product instead of maybe a topic cream or maybe a gel or any other type of vehicle.
Sorry, would you mind saying again? Our internet is kind of crazy here.
Recording in progress.
But I can think I can.
Am I able to write it in the chat?
Yes.
Perfect. Just 1 second. That's right.
You can. I would like to know what was your path of ideas and why you selected and spray your product instead of a cream or a gel or any other presentation. Oh, that's quite an interesting question. Can you understand me now?
Yes, go ahead.
Sure. Some of the points that we have that the NAD precursor have an expensive cost, and also the way they are presented, they don't have new benefits. So the idea of using the Saccharomyces boulardii, we could try to make it a little cheaper and also give it a new function that would be the probiotic function that we can gain on our value of our project, if I can say on the way. That's why we didn't think of, we evaluated the idea, but the Saccharomyces boulardii was the idea that could create a better project, if I can say like this.
Thank you. Emmanuel, your question?
Hi, team. Nice to meet you. I only have one question. How you know that this just will be surviving the human body? And you sure that this just will produce the NAD inside? Thank you.
Mhm. Okay, some of the researches on this way about the Saccharomyces boulardii show that it can have a upper life of 24 hours at least. So we're thinking on the pharmacokinetic way that we could give every day a dose that could contribute to we keep the levels of the yeast on the gut. So you could produce the necessity of each day and also keep the levels on a way we could maintain it. That's at least the idea.
Thank you.
Okay, thank you. Jazira.
Thank you, Christian. Hello, team. Congratulations for your work. So I have two small questions about the FBA analysis that you perform. So you optimize the fluxes of the metabolites that you require, right? But eventually you obtain for the biomass for the biomass you obtain a flux which was 0. So that means that your cells are not going to grow. So my question is, did you change the conditions to obtain a non-zero flux for the biomass? If you made these changes, do they correspond to the experimental conditions? I mean, in the fermentation process, let's say?
We have changed the parameters, but our yeast could not increase the biomass. Maybe because it's anaerobic condition, but our idea is not to colonize the git. We only want to form an R, but I don't know if I have answered, but I didn't understand the second question.
Yeah, I can rephrase that. So my second question is, you are proposing an experimental proof of concept for your project. So I think the experimental conditions in the FBA analysis would correspond from this experimental proposal. So is that correct, or did you obtain these changes from the literature?
We have chosen the parameters based on the literature and based on experimental articles. Maybe I can say like that. In anaerobiosis.
Okay, thank you.
Thank you. Matthias, please.
Hi, team. Thank you for the great project. I've got a question. So if you bring your product to the market, so how would the process, especially in Brazil, for the approval look like? Yeah, especially because it's a GMO. So maybe you can figure out the steps for the approval.
Oh, just me get it. You are asking on the law what we can go by the law system or more to the public environment? I didn't get the point that you are asking.
More the law, but you can also, yeah, put some points about the other part.
According to the Anvisa, that's the government organ that would go on this point, we have some areas that we can correspond because Brazilian law is kind of systematic. So it's one point inside other. So we can need to follow the GMOs legislation, but also the probiotics and the supplementer. According to these, we need to do the clinical analysis like it's explained on our page. First, we're going to use a phase of preclinic that's on rats and after analysis that could be used in patients like humans. That's the legislation. And about the public, we did a survey to analyze if, you are sending to everyone a GMO and is the public open to accept it? Yeah, according to that, if you can show that everything has followed the legislation and is proved to be non-dangerous, hey, yeah, we can consume it. That was a good answer.
Thank you, team. Andrea, please.
Hello, team. Thank you for the project, for the presentation. I wanted to ask on the biosafety of the project because, yeah, I think you touched it in the last question about the animal testing. So you mentioned that, of course, the nature of the project means that this could have to handle some animal testing. So I would like to ask, what measures are you planning to take in this situation? And if in any case it could be avoided, how you would do it, if you would do it?
Okay, about animal handling, I also asked our university about the corresponding laws to it, and we can follow on our laboratory. And on the point of the scientific approach, we are starting thinking on using the CD38 knockout to can make a comparative way because CD38 can degrade the NAD levels that did on upper way. So if you want to analyze how much NAD it's getting from our probiotic, we need to use it. That's also why we put the CD38 knockout on our presentation video. But we need to get a further analysis for a better plan to do the tests. That's also like it.
Thank you, team.
Thank you. Noah, please.
Hello, team. How are you? My question is directed to since you're working with a probiotic, those genes will be viable and still alive. Am I correct? It will be a problem if you let them live in the nature. Do you have plans to avoid the genes to escape? Do you have any way to contain the GMO without letting it into nature?
I'm sorry, we couldn't hear what you're saying. Your sound is low. Could you say a little louder?
Do you hear me?
No, yes, please. Just say a little louder and we can understand it.
Maybe I can paste the question directly into the chat.
Oh, if you don't mind.
You can place yours. Yes. Please pose your question in the chat.
Okay. Okay. Okay, is this one since you are working with a probiotic?
Yes, that's the one.
Okay. Oh, sure. It's quite an interesting point because it's already a organism that spread around the nature. But being a GMO, that's a point that we can analyze. But considering the modification we are doing, it didn't make it more hazardous or dangerous. And also, the Saccharomyces boulardii starts on halfway, so the quantity of it goes down after some time. And on market, we already have several different antifungic medicaments that can handle it with a easier way. So even if it spread, it wouldn't be difficult to handle it. And even being honest on this way wouldn't change a lot the mechanism. So that's a point we're considering.
Thank you, team. Shreya?
Yeah, so congratulations. This is a super cool project. And from your proposal, it already shows that you've thought about the idea and the problem very comprehensively. A lot of my questions were already asked by the previous judges, but one question is left out, which is that, so in your proposal, you've mentioned that you will be knocking out a few genes or like the enzymes, which will have an implication on your NAD plus metabolism. And you've also documented this in your pathway graphics as well as in your table. The question that I wanted to ask is, did you check what functions these enzymes would have outside of NAD plus metabolism, and what implication knocking these genes out would have on the cell itself?
Sure, that's quite an interesting point. We use the Saccharomyces genome database that already have a large way of analyzing multiple enzymes. And we have checked all the literature for each one of the enzymes we are knockouting. And even if you knock out it, the cell can continue living and it didn't affect on the significant way the yeast. It's like to consider that when we're making some knockouts, we have to analyze it on wet lab, but analysis was did on a careful way to avoid any problem for the yeast.
Okay, thank you.
Thank you, team. Manuel, please.
Hello, thank you for your presentation. I think that is a very interesting topic. Do you think you're thinking about the idea to try to use bacteria instead of yeast to make the probiotic final product? For example, if you use lactobacillus, maybe you will develop a more easy and a stable probiotic instead of yeast, for example. Do you thinking about the idea to use bacteria?
Another quite interesting question. On the start of the idealization of the project, one of the points that we was analyzing was the cost. And when we think on yeast, it's cheaper, and we can also use the technology of freeze drying that you can keep it for a long time on the market. So you could make it cheaper and have a longer shelf time. So this would be a good point for our product. That's why we focus on yeast.
Okay.
Thank you, team. Thank you, judges. Do you have any last questions? Yes, Mario.
Thank you, Christian. Hey, I'm back again. So understanding that in all that time we have very strange, maybe weird regulation for GMOs, did you consider it producing your NAT, NR using a cell-free system instead of producing it in Saccharomyces? If yes, or if not, why you don't keep going with that idea?
Yeah, we know the cell-free system, but if you do it, we don't get the probiotic benefit that one of the points of the project. That's why we didn't consider it.
Okay, thank you.
Thanks a lot.
Thank you, team.
Can
Well, thank you. Yeah,
say something?
of course.
The NR is how can I say lost in the past? Can be lost in the way or in the stomach, in the gastrointestinal tract. So the NR purified and it can react along this way. So we can optimize this using our yeast. Using our yeast. Reducing the losing of NR.
Thank you very much. Well, team, that's our time. So I'm going to thank you. I'm going to ask you to please leave the room, continue watching us on YouTube, and thank you, judges. We have another team.
Thanks a lot. It was a big pleasure.
Thank you, guys.
Bye. Thank you.
Thank you, guys.
So we're waiting for the other team to come. While the other team comes, you can take a bathroom break or water break.